Hi there, grade 9s, and welcome back to WorksheetCloud Maths. Sorry about that. Not a good way to start the lesson. I hope you're very well today, and I hope you're fit and healthy and looking forward to today's lesson. We're starting a brand new section today called Surface Area and Volume. So we're going to look at surface area and volume. And in a couple of series ago, we actually looked at area and perimeter, and that was to do with a 2D shape. So now we're going to introduce volume and surface area, and we are going to be looking at 3D shapes, and we are going to use some of the knowledge that we learned before to actually put into place this time, but extend on that. Right, let's get started. Okay, the first thing we're going to look at is the surface area of 3D shapes, and we are going to start with a rectangular prism and a cube. So the surface area of a 3D shape is the total area of the outside of the object. So if you can imagine any 3D shape, we're looking at the area of the outside of the object completely. So if it's a cone, it's around the top surface or face and the bottom face included. Okay, but like I said, we're going to start with a rectangular prism, and we're going to also start with a cube so that it makes it easier. By the time we get to the others, it'll be old hats. Right, so the surface area is measured in square units, just like the area in a 2D shape is measured in square units. So it would be millimeter squared, centimeter squared, or meters squared. Okay, so it's important to note the following. 1 meter squared is equal to 100 centimeters times 100 centimeters, because remember a meter is 100 centimeters. So if you multiply that together, you're going to get 10,000 centimeters squared. So 1 meter squared is the same as 10 to the power of 4 centimeters squared. Okay? And then 1 centimeter squared is equal to 10 times 10 millimeters, which is 100 millimeters squared, and that's 10 squared millimeters squared. So if you are asked to convert from the one to the other, you can just go back to this, write it down and keep it somewhere safe, and you will be able to then use this to convert. Right, so let's look at the surface area of a rectangular prism. Okay, there we have our prism, our rectangular prism. Remember, it's just a 3D version of a rectangle. Okay, so we're going to look at its length, which is the longest side, the breadth, which is obviously the side next to the length, and then what makes it 3D is that it has a height now. When we looked at area of 2D shapes, we were only looking at length and breadth. Remember that. Okay, we've now added on another dimension, which is the height. That creates a 3D shape. Okay, so to find the area of the surface area of the whole prism, you need to find the area of each face, and you have to add them all together. So if you have a look at this diagram, that is a face, that is a face, and then the top one is a face. Okay, so to get this one here, it would be length times height. To get this one here, it would be breadth times height. And so to get that one there, it would be length times breadth. Okay, so let's have a look. We can say that, like I said to you, length times height would give me this surface area and the one at the back that we can't see behind here. Okay, so there's two of those. There we have them, length times height and length times height. The next one we're going to look at is breadth times height. So that will give you that surface area and then the one on the other side there. And there you have two, breadth times height and breadth times height. And then the last one, it will be length times breadth. And that will give you the surface area of the one underneath as well as the one on top. So again, we have two faces that the same formula would apply to. Length times breadth and length times breadth. So what we can do is work out one of those, and one of those, and then multiply it by 2. So double it, in other words. So we're working out what we can see there, and then if we double it, we're going to include what we can't see. So actually, we can use this formula. 2 times length times height plus breadth times height plus length times breadth. Can you see I've put in the square brackets just because there are other brackets here, and we don't want the 2 to just apply to our first formula. The 2 has to apply to everything that is within the bracket. Okay, So all we're doing is we're finding the surface area for half of it, and then we're multiplying it by 2. Instead of multiplying that twice, multiplying that twice, multiplying that twice, it makes this formula very, very long. So let's just simplify it, and we go length times height plus breadth times height plus length times breadth, and we double it. We multiply it by 2. Right. Let's look at the surface area of a cube. This one is so much simpler because, as you know, a cube is the 3D version of a square. So there we have it, and we've got side, side, side. And the reason they're all called sides is because they are all the same measurement. Okay, so if you want to find the area of a cube, the surface area of a cube, we are going to find the area of one of the faces, or we can find them all and then add them together. But if we find one, we are going to be able to multiply it by 6, because if you find one face, it's the side times the side. You can see here side times side, or side times side. They're the same measurements. So, and there's 6 equal faces. We've got the 3 that we can see, and then the 3 that we can't see underneath, at the back, and on that side. So what can we do is we can say 6 times side times side, okay, which is a whole lot easier than trying to remember all the 3 different calculations that we need to do for a rectangular prism. But that is actually also very easy, as you have seen. Okay, let's go on. Let's put this into practice. So here we have a rectangular prism. We are given the measurements that the length is 18,2 centimeters, the breadth is 7,8 centimeters, and the height is 10,5 centimeters. So what do? We first apply the formula. So we write down the formula, and then we substitute into the formula. So length is 18,2, as I said, times the height, 10,5. It doesn't matter which way around you do this. If you want to go length times breadth first, or breadth times height first, it's completely up to you, because at the end you're going to add them all together anyway. Okay, so we're going to start with 18,2 times 10,5. Then we're going to do 18,2 times 7,8, and then we'll go 10,5 times 7,8. Right, so there we have it. We've multiplied everything together, our length times our height, our length times our breadth, and our breadth times our height. Okay, when we get 18,2 times 10,5 gives us 191,9. 18,2 times 7,8 gives us 141,96, and 7,8 times 10,5 gives us 81,9. Before we carry on, I just want to remind you that you must always put in your units of measurement. So already here we've got centimeters times centimeters. It's going to give us centimeters squared. Okay, again, centimeters times centimeters, centimeters squared, and centimeters times centimeters, centimeters squared. Now because you are adding them, it remains centimeters squared. It was only here because you multiplied them together, it would change from centimeters to centimeters squared. Okay, so now we have all like lengths, units of measurement. We can just add them together, and we're going to get 2 times 414,96 centimeters squared. Okay, and so we double that, and we can end up with 829,92 centimeters squared. Very often when you're calculating this, you need to round off to the nearest tenth, or the first decimal place, as they could say, or to the nearest whole number. If we were rounding off to the first decimal place, that would be 829,9. If we were rounding off to the nearest whole number, that would be 830. See, the 9 adds on here, which will affect the tens column. All right, everybody happy with that? Okay, quite a lot of calculating, but you can use your calculator, so it makes it a whole lot easier. Okay, let's do another one. There is our rectangular prism. It's in a bit of a different shape, but it's still a rectangular prism, and we've still got a length, a breadth, and a height. Okay, right, so we're going to go 2 times length times height, plus length times breadth, plus breadth times height. Sorry about that. Okay, so if you see that as the height, then you can substitute it in as the height. If you see that as the breadth, you substitute it in as the breadth. As I said, it really doesn't matter because you are multiplying them together and then you're adding everything together. So if you see that as the height, then you multiply it in and you multiply it by the length and then you multiply it by the breadth, which is obviously then going to be that one. Depends how you look at the diagram and what you see in the diagram. But if you use your formula and you substitute in, you won't go wrong. Right, so we've got 124 centimeters times 79 centimeters. We've got 124 centimeters times 58 centimeters, and then 58 centimeters times 79 centimeters. Okay, you end up with 9,796 centimeters squared plus 7,192 centimeters squared plus 4,582 centimeters squared. Okay, because you've calculated each of those. That's very big numbers, but it doesn't matter because these are not that small either. And remember, it is centimeters. Okay, so this one actually converts to just over a meter. All right, we add all of those together. We end up with 21,570 centimeters squared, and we have to double that. So multiply it by 2. We end up with 43,140 centimeters squared. Quite a big surface area, but remember, we're taking all our faces, finding the area of each one, and then adding them together. So that surface area is in centimeters squared, but it's all the way around the outside of this rectangular prism. Okay, everybody happy? All right, try this cube now. Okay, we've got a cube. We only need to know the length of one of its sides, because all the sides are the same length. So what do? We go 6 times by side times side. Okay, so it will be 6 times 45,6 centimeters times 45,6 centimeters. We end up with 6 times 2,079,36 centimeters. And if you times that by 6, you're going to end up with 4,158,72 centimeters squared. Okay, now again, like I said to you just now, you could be asked to round this off to the first decimal place, or you could be asked to round it off to the nearest whole number. So first decimal place would stay as 7 because there's a 2 there, and if it was to the nearest whole number, it would be 4,159. Okay, right, it's your turn. There are 3 shapes that are going to come up, and I would like you to try this on your own. So once you see the 3 shapes, there they are, you can pause the video and you can work out the total surface area. And then let's come back and see how you did. Right, let's see how you did. Okay, so we take our first shape. There are the measurements, the length, the breadth, and the height. Again, like I said, it doesn't matter how you substitute in because it's all going to come out in the end. It's all going to work out properly. All right, it is better to put the longest side in as the length, but even if you didn't, as long as you're multiplying everything together, so you multiply that by that, you multiply that by that, and then you multiply that by that. Okay, so there is our formula. We're going to substitute in. We've got length of 53,3 centimeters, our height of 30,2 centimeters. Then we're going to add it to our length of 53,3 centimeters times by our breadth of 21,1 centimeters. And then we're going to add that to our breadth of 21,1 centimeters times by our height of 30,2 centimeters. Okay guys, remember if you've got any queries, don't forget to send them to grade9@worksheetcloud.com if you're not sure of anything. If you think you've just missed something that I've said, just pause the video and go back and see what the formula is or how the explanation was done in the beginning. But I'm sure you're all keeping up and I'm sure this is all fine and you can see what I've substituted in. Right, let's work this out. Again, like I said, I know these numbers are quite big and sometimes difficult to work with, but if you've got a calculator, please use it. Right, so 53,3 times 30,2 is going to give me 1,609,66, and that's centimeters squared. 53,3 times by 21,1 is 1,124,63 centimeters squared, and 21,1 times 30,2 would give me 637,22 centimeters squared. Okay, like I said earlier, you've got all like measurements, so we can just simply add those together, and we're going to end up with 3,371,51 centimeters squared. Okay, we have to double that because we're trying to find out the other three sides as well, and we're going to end up with 6,743,02 centimeters squared. Did you all get that? I hope so. Remember, don't be shy to ask questions, so send your emails to grade9@worksheetcloud.com. Right, let's look at the next shape. Okay, there we go. Looks a bit squiff, that rectangular prism, but anyway, we've got a length, we've got a breadth, and we've got a height. So we're going to put in the formula, we're going to substitute. Please also don't forget to write down your formulas before you start working out. The formula is actually very important. Number one, it shows whoever's looking at your work that you know what you're doing. And number two, it guides you to make sure that you don't leave anything out because you've got to substitute in. Right. So we've got a length of 60 centimeters times by a height of 15 centimeters. Then we're going to add that to the length of 60 centimeters times by the breadth of 42 centimeters. Then we're going to add that to the breadth of 42 centimeters times by the height of 15 centimeters. And the bracket hasn't been closed there. Please don't forget to put in your straight bracket at the end, your square bracket. Okay, so 60 times 15 gives me 900 centimeters squared. Remember, centimeters times centimeters, centimeters squared. 60 centimeters times 42 centimeters is 2,520 centimeters squared, and 42 centimeters times 15 centimeters is 630 centimeters squared. We add all those together and then we double that. So we're going to add them together and get 4,050 centimeters squared. When we double that, we get 8,100 centimeters squared. So the surface area for this shape, this rectangular prism, is 8,100 centimeters squared. Right, let's look at the cube. We only needed the one side to be written down, and that side is 12,5 centimeters. So what do? There's our formula. It's nice and short. It's 6 times by side times side. Okay. So you're going to go 12,5 times 12,5 centimeters. It ends up being 156,25 centimeters squared. Times that by 6 because you've got 6 of exactly the same face, and it's going to give you 937,5 centimeters squared. Okay, everyone happy? Right, how about this one? This is a bit of a challenge. We get given that we've only got two sides, but can you see there's a diagonal that's put in on the one side and a measurement for that diagonal. Now you're probably thinking that doesn't help at all. So we've got a measurement missing, and in this case it will be the height. Okay, we do not have the length of that side or that side. Okay, so we've got the length and we've got the breadth, but we do not have the height. But have a look here. This forms a triangle, and this is a right angle. Because we know it's a right angle, it is a rectangular prism. Okay, because it's a right angle, we can apply the theorem of Pythagoras. Okay, so to work out the height, use Pythagoras. So you've got the hypotenuse, and I've named it like that because otherwise that h is going to get confused with the height. So what we have to do is the hypotenuse squared is equal to the length squared plus the height squared. Remember, hypotenuse is equal to the sum of the other two sides, right? We know the hypotenuse, it's 39, so we have to square that. And we know the length, it's 36, we have to square that, but we don't know the height. So if we square 39, we're going to end up with 1,521. And if we square 36, it's 1,296. And we still are left without knowing the height. So we subtract that, we take the 1,296 across the equal sign, we end up with 1,521 minus 1,296. We are going to get 225. Remember, that is the square of the height. So if we want to find the height on its own, we would have to square root, and we're going to end up with 15 centimeters being the height. We now have all three measurements that we are needing. We have the length, we have the breadth, we have the height. We've worked out the height here. Okay, so we're going to put it back into our formula, and it's going to be 36 centimeters times 15, 36 centimeters times 22 centimeters, and 22 centimeters times 15. And once you've got all of that, you're going to double it. Right, so we get 540 centimeters squared, 792 centimeters squared, and 330 centimeters squared. Add all those together, you end up with 1,662 centimeters squared. You multiply that by 2, and you end up with 3,324 centimeters squared. Right, are you happy? This is very important to work out. You can't just guess what that height is going to be. You are given other information that you can manipulate to make sure that you've got all your measurements for your rectangular prism. Okay, let's go on. Let's look at volume. Volume is actually a whole lot easier because the formula is length times breadth times height. And in a rectangular prism or a cube, we will know what the length, the breadth, and the height is. We might have to work it out like we did in the last one with Pythag, but we would be able to then still just multiply everything together. But this time, we've got centimeters times centimeters times centimeters, and that's going to give me centimeters cubed. Okay, we are multiplying three sides by each other, and whatever measurement they are, if it's meters, if it's millimeters, your answer is going to be in the cubed form. Right, so let's have a look at this one. We've got 10,5 centimeters as its height, 18,2 centimeters as its length, and 7,8 centimeters as the breadth. Okay, so all we're going to do is go length, 18,2, times breadth, which is 7,8, times height, which is 10,5. And there we have it. Multiply that out using your calculator. You're going to end up with 1,490,58 centimeters cubed. Okay, remember, centimeters times by centimeters times by centimeters, it's cubed. All right, let's now have a look at this one. You try this one. You know that it's length times breadth times height, and you know that they are all the same in this one. Pause the video, you try it out, and then when we come back, we'll go over it together. Right, let's see how you did. This time, its volume is equal to length cubed because the lengths are all the same size. So we multiply them out, 45,6 times 45,6 times 45,6. We're going to end up with 45,6 centimeters all cubed. So that you can write in that line if you would like to. Remember, you must write the cube on the outside of the brackets. Otherwise, it's just that, and it's just the centimeters that have been cubed. Right, so if we multiply that out, it's going to be 94,818,816 centimeters cubed. That's very, how can I put it, clumsy. So generally we will be asked to round off. Okay, right. That's all for today. It was quite a lot, but the most important thing is to know your formulas and be able to apply those formulas. Okay, and remember again, if you've got any questions, to please email grade9@worksheetcloud.com and somebody will get back to you with an answer. Right, thank you so much for listening to today's lesson, and I will see you next time in our surface area and volume series. Thank you guys. Keep well. Goodbye.